Hello, my name is Justin Zhang, and my project is called An Algorithmic Approach Towards Matching Document Word Usage and Sentence Structure to Corresponding Historical Timeframes. So my introduction. English is a very popular language in the world today. Over 20% of the world speaks English. And there's no doubt in my mind that the English language has changed. Even in my English class, we talk about how English took three forms: Old English, Middle English, and Modern English. And the question I'm trying to ask is, does the high malleability of language as a form of communication apply to American English? And that's why I developed my algorithm to answer this question. The purpose of my algorithm is to estimate the document's actual age, or year it was written, based on sentence structure and word usage. Applications of my algorithm include understanding modern variations of the English language, plagiarism detection, author identification, and restoring a certain piece of text to its correct position in the timeline. My null hypothesis is that the computer algorithm will not prove a difference in syntax distribution across 4 centuries and will show no relationship between the document's estimated and actual historical time frame. My alternate hypothesis is that the computer algorithm will prove a difference in syntax distribution across 4 centuries and will minimize the difference between the document's estimated and actual historical time frame. My experimental design. My dependent variable is the year it was assigned to the inputted document, otherwise known as the year where the document was written. My independent variable is the estimated year for my algorithm. The control variables are the algorithm itself, the time frame I'm studying, 1600 to 2000, and the 2 databases that I'm using. The trials I'm running are 40. Here are the materials. I'm using computer, Google Spreadsheets, the TI-89 calculator, Eclipse IDE, which is my coding platform, and the 2 databases that I'm using for this project. Here's my procedure specifically for sentence structure. I'll first randomly select 28,000 words from randomly selected documents, 7,000 per century. And then I would then develop an algorithm that matches every word in the document to a specific part of speech, otherwise known as I am finding the distribution of nouns, adjectives, verbs, and prepositions, and clauses across the 7,000 words per century. And here's my procedure for word usage. So I would first randomly select 40 documents, 10 documents per century. I would write a data collector so I can use the data, gather it from the Google database, and then use it on my own computer. I would then create a data structure, otherwise a storage, so that I can easily enter the data and access it whenever I want. I call it the storage node. I would then develop a data accumulator and collector, and this pretty much accumulates the total frequencies of each word in the document from the year 16,000 to 2000. I would then try to optimize my algorithm. So first I would find a minimum search date. Otherwise, if a word was first used in the year 18,000 or 1800, I would not estimate a year before 1800 because if the word was first used in 1800, there's no way for the document to have been written anytime before 1800. I would also try to optimize the algorithm by finding the years where it's statistically unlikely to have been written. For example, if the word frequency at a specific year is less than 10 to the negative 6%, then I would not consider that year as viable or a good estimate for my algorithm. After the optimization, I would find the maximum of my document's cumulative total word frequencies and return that year, and that is the year that I will be estimating. I would repeat this step, or all these steps, for all 40 documents. So here's the code for my sentence structure. As you can see, I'm organizing the parts of speech into the nouns, verbs, adjectives, prepositions, and clauses. Here's the code for the word usage. So as you can see, I am collecting the data from a certain website, and here's my first optimization. I would find the earliest year where the word was used. Here's my second part, the data accumulator. So I accumulate all the years, and here's my second optimization. If the frequency is below this certain percent for a certain year, it won't be considered as a possible answer. I would then find the maximum year where the frequencies are at the highest, and then I would return that year. So what exactly is my code doing? So I'm actually accessing all this data from my own computer and then optimizing it based on stuff I stated before, and I find the maximum total frequency of the word usage, and that is the year that I would be estimating. And here are the results. This one's for my sentence structure. Here's the distribution of nouns, verbs, adjectives, prepositions, and clauses for all 4 centuries, for all 4 time periods I'm studying. Here are the results for my word usage. I ran a linear regression analysis, and here is a comparison between my estimated and actual year. So on the y-axis, my estimated year, on the x-axis is my actual year, and here's my least square regression line of comparing the estimated and actual year. And here's the difference between the estimated and actual year. So as you can see from this graph, my algorithm was pretty accurate. It never went above 100 years in error, and it was actually very close to the estimated year. The difference being right here, 0, and here's all the stuff that my algorithm outputted. Here's my statistical summary. So the average error was 29 and the standard deviation was 20. The median error was 26, so that was very good considering that I'm studying over a 400-year time period. The minimum error was 0, so sometimes my algorithm did estimate right on the dot, and my maximum error was 88, which is pretty good because it never exceeded 100 years, and I am studying a 400-year time frame. So my statistical tests, I ran 3, the chi-square test for homogeneity, regression test, and the t-interval for means. So let's start with the chi-squared. I ran the chi-square test for sentence structure, trying to find a difference in the 4 centuries parts of speech and sentence structure. And I got a p-value of 1.32 times 10 to the negative 66. So that is a very, very conclusive answer suggesting that there is a strong difference between sentence structure across the 4 centuries. These are regression analysis. So I ran a t-test for slope, and I got a p-value of 1.65 times 10 to the negative 20, which shows that there is a strong positive relationship between the estimated and actual year. I also ran a 95% confidence interval, and I found the true slope of the regression line was between 0.81 and 1.02. And this is perfect because the ideal slope, assuming that my algorithm was perfectly correct, the ideal slope would be 1. And here's a 1 sample t-interval for mean test. And I found a 95% confidence interval for the true difference between the estimated and actual year, and that was 22 to 35. So that is very accurate given my 400-year time span. And here are the conclusions for my study. So from the time frame from 1600 to 2000, American sentence structure and word usage has changed significantly, as shown by my results, and this suggests that my alternate hypothesis was supported. My sentence structure and word usage can be used to differentiate documents written in different time frames, as suggested by my results. And the algorithm that I created successfully determined the correct time frame for the documents and exhibits statistically significant results. So as shown by my results before, my algorithm was pretty accurate in guessing the time in which the document was written. So for the study, I could improve the runtime of the algorithm. So in big O notation, the runtime is O of n to the 5th, and I know that my algorithm can be faster, and I know I can do it given extra time. I could also employ my algorithm to different kind of stuff that I want to be studying. For example, identification, security, and plagiarism detection. This all depends on the databases I'm using. So depending on the database, I can use this algorithm for a variety of purposes. I could also expand my algorithm to talk not only about American text, but also other stuff. So not only American English, but how about English in general? I could talk about French, Spanish, German, all that kind of stuff. I just need using different multiple corpora or different databases of words. And here are my references. And thank you for your time.